Okay guys, welcome to this video. Then I'll be doing this question there. Do you see? You should notice something about stochiometry guys. Stochiometry guys, it contains many marks there. Do you see? It got 26 mark from one question there. So please listen carefully guys. How do we approach this question? This question guys are straightforward. And now this question guys, I don't have its memo, but because I trust myself, yeah, I will do it with you guys. So this is how this thing it goes. They tell you that the reaction between magnesium and dilute hydrochloride guys, the reaction between magnesium and dilute hydrochloric acid is represented by the balanced equation below. So this thing is a balanced equation guys of magnesium and dilute hydrochloric acid. Yeah, represented balanced. Yeah, so during an experiment 1.5 grams of magnesium reacts with excess dilute hydrochloric acid to produce hydrogen gas at STP. Guys, this word guys, it's hard to pronounce this thing, but you can even read that statement. So here guys, you are given a balanced equation of these two compound that they react together, element and the compound they react together to produce that thing there. And now during our experiment 1.5 of this reacts there. So, okay, at STP, don't forget that at STP there, calculate the mass in grams of hydrogen gas produced guys. So here guys, let me just take this information, all of it. So this is the information that we're given. By the way, S plus 2HCl. This thing guys, it's aqueous, and this one it's a what? It's a solid. Solid and aqueous, and G, which is Cl2 and aqueous, and then they say plus 2 gas. Do you see? H2, meaning it's a hydrogen gas, that one. So the info guys that they gave you there, they gave you the mass of this thing there, which is 1.5 grams. Do you see? Yeah. And now they told you that this thing, it happened where? At STP, meaning that we know the volume there, which is 2.4 decimeter cube there. So we know the volume of a gas at STP there. The volume of a gas at STP, and now the one which is a gas there, it's a hydrogen there. Do you see? Yeah. So that one, it's a volume of a gas at STP, and now the question now, it is asking about the mass of what? Of hydrogen gas guys. How can we get that mass? So here guys, you should be smart. This thing is a 6-mark question there. Not every learner there can get this thing right. Try to listen this thing carefully. So for this question, for me to solve this question guys, straightforward. What you can just do about this question guys, here you should act smart guys. A first thing that you should do in order for you to know a mass of this thing, first of all, we should know the a moles of this thing there. If we can know the moles of this thing, okay, let me just write this equation. If we can know the moles of this thing there, if we can know the moles of this, we can get that, because that one they will get it from where? From a periodic table, obvious. Do you see? But how can I get the moles of this guys? For me guys, to get the moles of this thing, don't even think about this equation, by the way. Yes, I have this thing, it's constant, but I don't have a volume. Do you see? So I can't have this thing while I am not given a volume. This one there, I know that one it's constant, is that one? No. This, it is this, but now I don't have a volume. So this equation, it won't be applicable for this question. No. So a key thing that I will do, here I should apply what we call a molar ratio. What is a molar ratio, guys? A molar ratio, guys, it is whereby we will compare two compounds here. Two compounds, which is there. This is a compound that I can, which is this, and I will compare with this one there. Do you see? Yeah. Then what I will do there, I will take their coefficients. Coefficient of this thing, guys, it's invisible 1. Coefficient of that one there, it's invisible 1 there. You see? And now the mole that I want to solve, it is for this there. I want to solve the mole of that thing. Do you see? And that mole, for me to solve it, first of all, I should know the moles of magnesium. And for me to know the moles of magnesium, I'm given that information. It means now I'll start from here, by the way. Molar mass of magnesium. I'll use my periodic table there, which is a molar mass of magnesium, it's 24 there. Do you see? Meaning there I can say this thing, it's 24 grams per mole. It's grams per mole. So now I can apply this equation, which is this. Then I can substitute there, meaning here I'm given that it's 1,5 divided by 24, meaning that the moles of magnesium there, of magnesium, will become, I'll use my calculator there, divided by what? 24, meaning this is what I get there, guys, which is this thing is 0,0625 say mole there. Do you see? So now I know, guys, the moles of what? Of magnesium. I'll take those moles, I'll put them here, which is 0,245 there. So now I have a chance for me now to compare those moles there. For me to get the moles of this, I can just do a cross multiply. This will multiply there, that will multiply there. Meaning that anything when you multiply with one, you'll get the same thing there. And this multiply with that one, you'll still get the same thing there. Multiply, still there, you'll get the same thing, which is this H2O there. And now say mole. Do you see? So now, guys, I know the moles of what? Of hydrogen gas there. Once I know the moles, guys, of hydrogen gas, I can apply this equation for me to get what? A mass there of hydrogen gas. But before I apply that equation, let me start by finding a what? A molar mass. For you to get that molar mass, you will just use your periodic table again, whereby you will say 2 multiply a mass of this thing, it's 1 there. According to our periodic table, a mass of hydrogen, guys, it's 1. But that 2, guys, because we got 2 of hydrogen there, meaning now our answer will be this grams per mole there. Yeah. So now I got this info. It means now I can apply that equation of, then I substitute that this thing I already calculated, and this one that I calculated. So it simply says, okay, now this is what will happen there. I'll do cross multiply, put invisible 1, this go there, this go there. Anything multiplied by 1, you'll get the same thing. This multiply that 1. It means, okay, now my final answer, let me press this thing on my calculator, which is this one multiply that, which is, this is what I get, guys, as an answer, which is 0,125, which is there, it's grams. But now you can round off your answer in 2 decimal place, meaning this thing that will be a mass of hydrogen gas was 0,13 grams. Do you see? This one, it's a level 5 question mark get there. Ne? Not any learner guys can get this question. This one it's for the chosen ones. Ne? So our marks will come from here. 1, 2, 3, 4. Do you see? Yeah. And now from the equations that we use, this equation and that equation, meaning it's 1, 2, 3, 4, 5, 6. Do you see? Yeah. Marks here guys, they come easy. They come from equations there. And now the next question to you will simply say now, calculate the volume of hydrogen gas produced at STP guys. If that question there guys, you do it correct, it will be easy for you to get that one right. Yeah. But yeah, if this one you do it correct, it will be easy for you guys to get this one right, because now this is what will happen there. We know the moles of hydrogen gas, and we know